Hey everyone, welcome back to my channel, Beaker and the Board. Today I am here with a very important topic, especially for your competitive exams. So before heading on to that, we need to know why do we need to study this IUPAC nomenclature. It is a very easy topic if you understand, so please focus on the class. So why do you need to know the IUPAC nomenclature? So previously, when not many organic compounds were discovered, the organic compounds were very limited in number. People used to give the name of organic compounds from their sources. Like for example, if I say you must have heard about formic acid. Formic acid was is obtained, actually the source of formic acid is red ant. The red ant, the Latin name being formicus. Since formic acid is taken from formicus, that is why the name is given as formic acid. Then butyric acid. Butyric acid source is butter. Then acetic acid is obtained from vinegar. The Latin name of vinegar is acetum. Urea is obtained from the urine of animals. So in the previous time, when many organic compounds were not discovered, they were named according to their source. But gradually, with progress of time, more and more organic compounds came up, because you have heard about that carbon has catenation property. Catenation means the self-linking property of carbon. Carbon can link with each other. One carbon gets linked with another carbon. The linking property of carbon atom, through which they can make long chain or branches or cyclic compounds or aromatic compounds. So due to the catenation property of carbon, many organic compounds came up gradually. Many more were discovered. So it was difficult to remember the natural source of every compound. That is why a more methodical process came up, that is writing the IUPAC nomenclature of compound. So IUPAC nomenclature is given just in a mathematical form so that it is easy. You don't have to remember, you don't have to memorize. By knowing simply the rules, you can write the IUPAC nomenclature of the compounds. So before that, what are alkanes? I hope you must be knowing that alkanes are saturated hydrocarbons, right? The first class is regarding alkanes. I'll slowly come up with the different topics. I'll show you the IUPAC nomenclature of alkenes, of alkynes, of compounds having cyclic groups, having functional groups, more than one functional groups of aromatic compounds. I'll be giving you videos regarding everything. Now, the first thing is alkanes. What are alkanes? Alkanes are the saturated hydrocarbons. Alkanes are saturated hydrocarbons. What is the meaning of saturated hydrocarbons? Hydrocarbons simply means, as the name suggests, compounds having carbon and hydrogen only. Compounds having only carbon and hydrogen atom. So, now next comes the topic of saturation. What is the meaning of saturation? Saturated hydrocarbon. Saturated means having only carbon-carbon single bond. Only single bond will be present in the entire compound. There will be not a single double bond, not a single triple bond. Other heteroatom like OH or halogen, any other group may be present, but it should not have any double bond or triple bond. So how to write the nomenclature of some compounds? We need to focus on some rules. The first rule of writing the IUPAC nomenclature of alkanes is to select the parent chain. The first rule is select the parent chain. Now, what is the meaning of parent chain? Selection of parent chain. What is the meaning of parent chain? The first criteria is it should be continuous. Parent chain is that which is continuous. You cannot skip, you cannot jump any atom. You cannot suddenly jump to any atom which is not bonded. The next one is it should have maximum number of carbon atoms. It should have maximum number of carbon atoms. Let's take an example. Say, if I say take this example as CH3, CH, then comes CH2, CH3. I'm teaching you first how to select the parent chain. Then CH2, CH3. Suppose this is the compound given to you. As I said, that the first task will be to select the parent chain. And it should be continuous. You cannot skip to any atom. Let's take an example. Say, if I choose this bond, this as the parent chain. If I take this as the parent chain, I hope you can see that there it is a continuous chain. I am not skipping any atom. I am not skipping any atom. Suppose if some of you say, ma'am, if I consider like this, 1, 2, 3, 4, then 5, 6. Can I do that, ma'am? Is it possible that I can suddenly I'm moving on that way? If two carbon atoms are not bonded to each other, you cannot consider that as a part of the parent chain. They should be continuous. The parent chain will be continuous. Those carbon atoms which are not bonded to each other will not be considered as a part of the parent chain. Now see, if I take this, this one is not possible. The next one is, I'm explaining you once again. Suppose if you say that, ma'am, can I select this one? 1, 2, 3, 4, 5, 6. Just to include maximum number of carbon atoms, you cannot take those carbon atoms which are not bonded to each other. If I go in this way, we are including all the carbon atoms, but they are not bonded to each other. As I said, just to form the longest chain, just to include maximum number of carbon atoms, you cannot consider those carbon atoms which are not bonded to each other. Suppose if I label them, it will be easy for you to understand. If I label them as A, B, C, D, E, F. See, carbon atoms A, B, E, F, they form a continuous chain because they are bonded to each other. Then carbon atoms A, B, C, D, that also form a continuous chain. But if I say A, B, C, D, and then from D you are moving to E, and from E to F, is that possible? This is not possible because D and E are not bonded. D and E are not bonded to each other. So just to make the longer chain, just to include more number of carbon atoms, you cannot consider those carbon atoms which are not bonded to each other. As I said, A, B, E, F, they form a continuous chain. They are bonded to each other. A, B, C, D, they are bonded to each other. They form a continuous chain. But suppose if you want to move from A to B, then B to C, then C to D, and then from D to E and E to F, D and E are not bonded to each other. You cannot make this as a parent chain. I hope this continuous word is clear to you. The next one is the including the maximum number of carbon atoms. What should you do to include? You can also say, ma'am, can I include D, then C, D, C, B, E, F? Can I consider this as a parent chain? Is it continuous? Yes, they are continuous. D, C, B, E, F, that is a continuous chain. You can consider that as a parent chain. You can consider that as a parent chain. So, what happens? If I take this as the parent chain, this as the parent chain, see, That means DCBEF, that is my parent chain. That becomes my parent chain. It is not only continuous, but it is also having 5 carbon atoms. All the other carbon continuous chain that I have said, ABEF, that is continuous but has 4 carbon atoms. ABCD, that is also continuous but has 4 carbon atoms. But DCBEF, that is continuous and also has 5 carbon atoms, having maximum number of carbon atoms. So that means DCBEF forms my parent chain. So while selecting the parent chain, you need to keep in mind that it should not only be continuous but should also be having maximum number of carbon atoms. And I have taught you very well how to understand what makes a chain continuous. The atoms should be linked to each other. Only then you can consider that as a part of the continuous chain. The next thing is, after selecting the parent chain, after the parent chain is selected, what do you need to do? The next rule is providing the locant. After selecting the parent chain, you have to give the locant. You have to numbering the parent chain. Numbering the parent chain. Suppose if I take this example only, CH3, CH, CH2, CH3, and this side CH2, CH3. So that means what happens? This becomes my parent chain. This becomes my parent chain. Now while numbering, how will you number? You have to number in such a way that the carbon atom bearing the side chain is given the lowest locant. Carbon atom carrying the side chain, is given lowest locant. Locant means the number. Now what is the meaning of side chain? Side chain is something which is outside the parent chain. Something which is not a part of the parent chain will be considered as the side chain. That means here this CH3 is my side chain. The CH3 is considered as the side chain because it is not a part of the parent chain. Now how will you number? Numbering again, see for example, if I number in this way, 1, 2, 3, 4, 5. If you start numbering from down, then what happens? The side chain comes in the third carbon atom. If you start numbering from the downside, then what happens? The locant is 3. That means at the third carbon atom, we get the side chain. If you start numbering from the upside, right hand side from the upward side, see, suppose if my numbering is this, 1, 2, 3, 4, 5. From both sides, the locant comes to be 3. So you can select any of them. That means at the third carbon atom, our side chain is present. Numbering from any side gives the same locant. Now, suppose if I give you another example of numbering. Suppose if I say CH3, CH, CH, then CH2, CH2, CH3. Now I am teaching you with respect to the condensed formula. Very soon I'll be proceeding to the bond line formula. If you have not followed my previous video, please understand how to comprehend the bond line formula first. This is the compound given to you. Now, first thing is selecting the parent chain, which is continuous as well as it should be long. Now, let's see what comes to be the parent chain. This is the parent chain that we have got. Because it is not only continuous but also having maximum number of carbon atoms. If I label them, suppose if this is A, B, C, D, E, F, G. Now see the parent chain from A to B to C, then D, D to E, E to F, and from F to G. You can say, ma'am, A and D are not bonded. That doesn't matter. I am not directly connecting A and D. A to B, B to C, C to D, D to E, E to F, F to G. This is how they are connected. That is the continuous chain. And see how many carbon atoms are there. We are having 7 carbon atoms. So it is long. Find out if it is possible to give another chain, but it should have maximum number of carbon atoms. It should be having more than 7 carbon atoms. If it is possible, find out and comment down. And then after this, we need to find out the locant. That means what is our side chain? This is our side chain, and this methyl is also our side chain. Now how to number? Again, numbering should be given in such a way that it gets the lowest locant. It gets the lowest locant. Let's number now. If I number from downside, what happens? 1, 2, 3, this is 4, 5, 6, 7. If I number from the down, then what are the locants? We are having at the 4th position one side chain, and at the 5th position we are having another side chain. Then, and if I number from the right hand, from the upside, from the upward direction, then what happens? This is 1, 2, 3, 4, 5, 6, 7. That means if I start numbering from the upward direction, then the locants are at the 3rd carbon, there is a side chain, and at the 4th carbon, there is a side chain. So when you give the locant, when you number the chain, you need to remember that the locants get the side chain. The carbon atom having the side chain gets the lowest locant. If you start numbering from the downside, from the black numberings, if you start numbering from the downward side, then what happens? You simply give the higher locants. You are simply giving higher locants. That is why what is done? We are giving numbering from the upward direction. The 4, 5 locant is wrong. The 3, 4 locant is correct. 3, 4 locant is correct. The 4, 5 locant is wrong because it is having more. The locant should be in such a way, the carbon atom carrying side chain should get the lowest locant, should get the lowest number. That is how you need to number. Now see, after that, let me give you another example of numbering so that it is deeply into your head. Suppose if I want to do this, CH3, CH2, CH2, CH3. So obviously you can understand that this becomes the parent chain. This becomes the parent chain. This becomes our parent chain and this becomes the side chain. Now how will you number? While numbering, again, let's take the example 1, 2, 3, 4, 5. If you start numbering from the right hand side, then what do you see? If you start numbering from the right hand side, then at the second carbon atom, CH3, that is the side chain, is present. But if you start numbering from the left hand side, that means if I show you the numbering with green color, then what do you get? That means if you start numbering from the left hand side, you see that at the fourth carbon, the side chain is present. So obviously the right hand side numbering is correct, but the left hand side numbering is wrong. Left hand side numbering is wrong. So numbering has to be done in such a way that the carbon atom carrying the side chain gets the lowest locant. Now after the location is given, after the numbering is done, what do you need to do? Suppose if I give you another example, say, suppose if you have this kind of numbering. I am proceeding to the bond line formula now. It is easier, less time consuming. This is the compound given to you. Now see, what is your side chain now? Your side chain is this. This is your side chain. And what is the, this is the parent chain, and what is your side chain? This and this. The blue ones are the side chains and the brown one is the parent chain. Now what will you do next? Next comes the numbering. How will you do the numbering now? So this is the side chain, these two. Now 1, 2, 3, 4, 5. Now see, for this the numbering comes to be 3 and 4. At the 3 and 4 carbon atom, side chains are present. Again, if I number from the opposite side, I am showing you with a different diagram. 1, 2, 3, 4, 5. That means the side chains are present at 2 and 3 carbons. So this numbering is correct, this numbering is wrong. I hope this is clear. After that, we need to find out that arrangement of the, how to write the compound now. Suppose for example, if you want to write this compound, if you want to write the nomenclature of this compound, what will you see? What are the side chains? The side chains are methyl. How do you denote methyl? CH3 is called the methyl group. CH3 is called the methyl group. So how do you write that then? 2, 3. 2, 3 dimethyl, then pentane. There is a very simple format for writing the IUPAC nomenclature. Please write down the format in your copy, note it down so that it becomes easy for you to write the IUPAC nomenclature of any compound that is given to you. It may look to be hard right now, but gradually as you proceed with complex compound, it will be deeply into your head. So what is the formula? What is the format? The first format is side chain with locants in alphabetical order. Side chain with locant in alphabetical order. This is the first thing. So whenever you write the IUPAC nomenclature, you will always write the side chain first with the locants. See, in this compound, what is the side chain? We are having two methyl groups, 2CH3, right? 2CH3 is there. That means methyl group. What is the locant? 2 and 3. So as I said, side chain with locants in alphabetical order. Now, when do you follow the alphabetical order? The alphabetical order is followed only when there are different types of groups. Suppose if one is methyl and the other one is ethyl. In such cases, you will follow the alphabetical order. Here we are having two methyl groups, two similar groups. That is why the alphabetical order is not followed here. 2, 3 dimethyl. So always write the side chain first with the locant. If you are having different side chains, then you will follow the alphabetical order. After that, from side chain, you will move to the cyclo. The word cyclo will be included. If the compound has any cyclic rings, like for example, if there is any cyclopropane or cyclobutane or cyclopentane, if there is any cyclic ring in the compound, then you include cyclo. If it is not there, just exclude this word cyclo. Cyclo word is included only when the compound has a cyclic group in it. If it is not having a cyclic group, simply chop it off. No need to think of it. Then after the cyclo, what do we write? We write the word root. Word root. What is the meaning of word root? Word root means the number of carbon atoms. Number of carbon atoms in parent chain. Number of carbon atoms in the parent chain. Like for here in this question, we are having 5 carbon atoms. I hope you know that whenever we are having one carbon atom, if the compound has only one carbon atom, we write meth. Meth. If the compound has 2 carbon atoms, we write eth. If the compound has 3 carbon atoms, we write prop. If the compound has 4 carbon atoms, we write but. Then, if the compound has 5 carbon atoms, we write pent. If the compound has 6 carbon atoms, we write hex. If the compound has 7 carbon atoms, then we write hept. If the compound has 8 carbon atoms, we write oct. If the compound has 9 carbon atoms, we write non. If it has 10 carbon atoms, we write dec. So that means whenever we say word root, we simply mean the number of carbon atoms in the parent chain. In this compound, we are having 5 carbon atoms. So we will be using pent. After the word root is written, what do you need to do? After the word root, you will include N. That means depending on the number of carbon atoms in the depending on the nature of carbon-carbon bonds. If it is carbon-carbon single bond, it is N. If all the bonds are single bond, then it is N. If there is one double bond, then we say in. If there is a triple bond, then we say ein. Okay, now N or in or ein. Just a minute. N or in or ine. Now the thing is, whenever you write ene or ine, I will be teaching you later. Whenever you write ene or ine, you need to give the locant. For ane, for single bond, you don't need to give the locant. But if you are having a double bond or a triple bond, you need to give the locant. You need to provide at which carbon atom the double bond or the triple bond is present. After that, we move to the suffix of the principal functional group. Suffix of principal functional group. This is the format for writing the IUPAC nomenclature of any compound given to you. How much ever complex it is, follow this format, your IUPAC will be correct. Now in this compound, we are not having any cyclic group. It is simply a simple compound. No cyclo group is there, so simply chop off this word. We are not having any double bond or triple bond, so simply chop off this. Ene or ine is not needed for this compound. Then we are not having any functional group, so no need to think of that. So how do you write? See, 2,3 dimethyl. So along with the locant, I have written the side chain. Now why dimethyl? Why are we writing di? When do we include these prefixes? Di, tri, tetra. When do we include these prefixes? When we have more than one. Now you may say, ma'am, why do you need to write 2,3? If I simply write 2 or if I simply write 3, is it okay? No. You need to give the locant for both. There are two methyl groups, one at the 2 carbon and the other at the 3 carbon. So both locants need to be provided. 2,3, not 2 only and not 3 only. 2,3 dimethyl. Side chain is named. After the side chain, we write cyclo. Cyclo is not there, so omit it. After that, word root. We are having 5 carbon atoms in the parent chain. So pent. We are having 5 carbons in the parent chain. Don't include the carbon atoms of the whole compound. Don't include the side chains. When we write the word root, we only follow the carbon atoms in the parent chain. And then it is having only single bond. So ane or ene or ine. After this, the next one. Suppose if I provide you this compound. What if you might be saying this, ma'am, if I have this kind of compound, if I'm having this kind of compound, then what? You can see very clearly that at the same carbon atoms, how many carbon atoms are there? See, 1, 2, 3, 4, 5. This is our parent chain. And this 2 forms the side chain. These 2 forms the side chain, the red ones. This forms the side chain. Now let's number the parent chain first. 1, 2, 3, 4, 5. There are 5 carbon atoms in the parent chain. Now you may be seeing that at the second carbon, at the 2 carbon, both the methyl groups are present. You may say that, ma'am, do I need to write 2, 2? Yes. You cannot write only 2 once. You may be thinking that both the methyl groups, both the side chains are at the same carbon atom. Both the side chains are at the same carbon atom. So do I need to write 2 twice? Yes. 2, 2. If you write only 2 dimethyl, if you write 2 dimethyl, it will be wrong. This is wrong. It is 2, 2 because it doesn't matter if the side chains are with the same carbon atoms. You need to write them several times. Since we are having 2 side chains at the 2 carbon atoms, so it is 2, 2. dimethyl. So side chain naming is done. After the side chain, what will we do? 2,2 dimethyl. Then cyclo is not there, side chain is named. Then pent in. This is how you write. Now see, I'm giving you few more examples, right? See, suppose compound 1. I have given 2, both are same. A and B, both are same. I am teaching you the numbering right now. See, this is the parent chain. This is the parent chain. I hope you can understand. This becomes the parent chain. After the parent chain, what happens? See, this becomes the side chain. These 3 are the side chains. The main task of finding the parent chain and side chain is done. After that, how will you number? Because the main task is that, giving the number, giving the locant. See, if you number from the left hand side, 1, 2, 3, 4, 5. If you number from the left hand side, what do you get? That at the 2 position, 2 methyl groups are there, 2 side chains are there. Not only methyl, side chains are there at the 2 position. So 2, 2. And at the 4th position. So it is 2, 2, 4. And see representation B. If I number from the right hand side, both A and B are the same compounds. I have just given 2 representation to make the numbering easier. If I number from the right hand side, then it is 1, 2, 3, 4, 5. If you see the numbering from the right hand side, what are the locants? It is 2, 4, 4, because at the 2 position, only 1 side chain is there. And at the 4th position, 2 side chains. So it is 2, 4, 4. Now the question is, which numbering is correct? Is the left hand side correct or the right hand side correct? Whenever this kind of confusion arises, what will you do? Compare the locants. Compare the locants. See the first locant. The first locant is 2. From the right hand side also the first locant is 2. So that means if you compare the first locant, you will not understand. The second locant from the left hand side is 2. But from the right hand side, the second locant is 4. That's where the confusion is dismissed. Always providing the lowest locant. If the first locant is same, move to the second locant. Even if the second locant is same, move to the third locant. Here the confusion is cleared in the second locant itself. Numbering from the left hand side, the second locant is 2. And numbering from the right hand side, the second locant is 4. That means right hand side numbering is wrong. The left hand side numbering is correct. So what is the IUPAC nomenclature of this compound? It is 2, 2, 4. Since all the side chains are same, so I am writing together. 2, 2, 4. We are having 3 groups, 3 methyl. So it is trimethyl. Trimethyl. 2, 2, 4 trimethyl. Side chain done. After the side chain, we get the cyclo. We don't have any cyclic ring here, so cyclo is omitted. Now, 2, 2, 4 trimethyl, then word root, pent. We are having 5 carbon atoms in the parent chain, so pent. All the carbon atoms are single bonded, so N. When you write N, you don't need to give any locant. But if you have a double bond or triple bond, you need to provide the locant. En or ine, you need to give the locant. Which position that double bond or which position that triple bond is there. After that, the next compound is 2. Let's move to the second compound. So the second compound is selecting the parent chain. Let's select the parent chain first. It is like this. You can consider this as well. It is same. You can consider this as well. You can consider the straight one. You can consider the downward part also. Straight chain does not mean it will be horizontal always, or it will be vertical always. It can be zigzag as well. Parent chain need not be straight every time. It can be zigzag as well. So what happens? This becomes the side chain. These are the side chains. We are having two different side chains right now. I hope you understand that this part is C2H5. This is C2H5. And this one is CH3. CH3. Right? Here we are having two carbon atoms, 1 and 2. That means in one side chain we are having only one carbon atom, CH3, and in the other side chain we are having two carbon atoms, C2H5. So what happens? Let's number now, right? After the parent chain is selected, numbering has to be done. Let's see which numbering is correct. 1, 2, 3, 4, 5. If I number from the left hand side, it becomes 2 and 3. 2 position we are having the methyl group, and 3 position we are having the ethyl group. And if I number from the other side, let's take another representation. If this is my parent chain, then the numbering, if I do the numbering in this way, 1, 2, it's like this actually, just a minute. It is this compound. So this is my parent chain. This is my parent chain. Now see, numbering. Let's do the numbering right now. Then 1, 2, 3, 4, 5. If you start numbering from the down side, then what becomes? The locands are 3 and 4. 3 position we are having the ethyl group, and at the 4th position we are having the methyl group. That means this numbering is wrong. Always select the lowest locand. The left hand side numbering is correct. So what is the name of this compound then? How to write the name of this compound? The name of this compound, I'm erasing this one. The name of this compound then becomes, it is 2-methyl, 3-ethyl. Now see, we are having two different side chains. One is ethyl and the other one is methyl. As I said, side chain with the locands in alphabetical order. So obviously we are having two different side chains here. We need to follow the alphabetical order. At the 3 carbon we are having ethyl group, and at the 2 carbon we are having methyl group. Ethyl E comes first. All of you must be very well acquainted with ABCD, right? You have been learning that from class 9. So ethyl E comes first. From nursery you are learning that. So it is 3-ethyl. 3-ethyl E comes first. So ethyl will come first. Then 2-methyl. 3-ethyl, 2-methyl. You may say, ma'am, but 2 comes first. 3 comes later. Numbering rule is not, number sequence is not followed. Alphabetical sequence is followed. So ethyl E comes first. That is why I have written 3-ethyl, 2-methyl. Then after the side chain, my work is word root. No cyclic ring is there, so it is word root. It is having 5 carbons. So pent. 3-ethyl, 2-methyl, pent, all are single bonded, so N. 3-ethyl, 2-methyl, pentane. The next compound, compound 3. See the parent chain. We are having 3 groups here. See, this is the parent chain. This is the parent chain. Sequential, continuous, and having maximum number of carbon atoms. So what happens? The other three, these groups, bromine, chlorine, and CH3 becomes the side chain. Now the numbering. How will you number? In such case, let's number from the left hand side first. If you do the numbering from the left hand side, what happens? 1, 2, 3, 4, 5, 6. From the left hand side, the locants become 2, 3, and 4. And if you do the same, if you take the same compound and number from the opposite side, let's see now. 1, 2, 3, 4, 5, 6. If you do the numbering from right hand side, then it is 3, 4, and 5. At the third position, bromine is there. At the fourth position, methyl is there. And at the fifth position, chlorine is there. Now see what is the correct rule. The left hand side numbering is correct. Right hand side numbering is wrong. The first locant itself will clear that to you. For left hand side, the first locant is 2. For right hand side, the first locant is 3. That means from the first locant only, the confusion is cleared. So right hand side numbering is wrong. So what is the correct nomenclature for this then? The correct nomenclature becomes like this, something like this. See, it is 2-chloro, now chloro C. Chloro C, bromo B, and methyl M. Again, follow the alphabetical order. What happens? B comes first. So it is 4-bromo, then 2-chloro. Side chain with the locant in alphabetical order. 4-bromo, 2-chloro, 3-methyl. 3-methyl. All the side chains are named. No cyclo. Move to word root. Word root is having the parent chain is having 6 carbons. So hex. All are single bonded to each other. So N. 4-bromo, 2-chloro, 3-methyl, hexane. Right hand side numbering is wrong. Let's move to the next one. The fourth compound. Now see the numbering. Here there is no other side chain, we can understand. So bromine and chlorine becomes the side chain. It is not a part of the carbon chain, right? Anything which is outside the carbon chain will be considered as the side chain. Now 1, 2, 3, 4. If you do the left hand side numbering, then what happens? The locants are 1 and 4. The locants are 1 and 4. And if you write the same compound once again, and if you do the numbering from the right hand side, 1, 2, 3, 4. I hope you understand the bond line formula. 1, 2, 3, 4. 4 carbon atoms. There are 4 carbon atoms, right? 1 bromine and 1 chlorine. So what happens? Here now see again from the right hand side also the locants are 1 and 4. Here the confusion may arise. The question is, you may say, ma'am, which one is correct? Because from both the side, left hand side and right hand side, we are getting the same locant. 1, 4, 1, 4. If I consider the left hand side, the name will be like this. It is 1 bromo, 4 chloro, butane. You may say this. And some other one may say Ma'am, why not 4-bromo, 1-chlorobutane? Are both of them same? No. The left hand side one is correct, this one is wrong. 4-bromo, 1-chlorobutane is wrong. So remember, whenever two sets of numbers are equally possible, the alphabetical order of the substituent is given more importance. That means from the left hand side, if the left hand side numbering is correct, right hand side is wrong. Why is it so? That is because bromine B comes first. So it is given the lowest locant. Chlorine C comes later. It is given the higher locant. If numbering from both the sides give the same locant, in that case, you need to give the lower locant to that group which is alphabetically faster, which comes earlier in the alphabetical sequence. Bromine B comes first, so it is given lowest locant. Chlorine C comes later, so it is given the higher locant. That means, remember, this is a very important point. Whenever numbering from both the sides are same, in such situations, the alphabetical order is given more priority. The group which comes earlier in the alphabetical sequence is given higher priority, is given the lower locant. And the group which comes alphabetically later, chlorine C comes later, so it is given the higher locant. Bromine B comes earlier, so it is given the lower locant. The group which is alphabetically before is given lower locant, and the group which is alphabetically later will be given higher locant. But this rule is not followed every time. It is followed only when the numbering from both the sides are same. Left hand side 1, 4, right hand side also 1, 4. In that case, what will you do? The group whose alphabetically is earlier, the group which is alphabetically earlier will be given lower locant, and the group which is alphabetically later will be given higher locant. Bromine B comes earlier, so it is given the lower locant. Chlorine C comes later, so it is given the higher locant. But it is not followed every time. It is followed only when both the sides numbering are same. The next one. What if the compound has a complex side chain? See this one. You may be terrified to see this kind of compound, but follow this, it is very easy. If a compound has more than one side chain and the side chain is complex, what will you do in that case? Please pause the video and write it down. Please write down the rule so that you can practice later. If a side chain is complex or branched, the side chain is itself branched, complex, then what will you do? The side chain is named as a substituted alkyl group. By giving number to the carbon atom attached to the main chain as 1. Let me explain to you first, then you will understand. Suppose if I consider this as my parent chain. Let me divide this, it will be easy for you. C2H5, instead of C2H5, I am writing CH2CH3. Let me see the parent chain first. 6, 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We include another one. One, two, three, 4, 5, 6, 7, 8. Suppose this is the compound given to you. This becomes your parent chain. This becomes the parent chain. Parent chain. Now what are the side chains here? This is the side chain. This is the side chain. And this also becomes a side chain. Now this one is ethyl, very easy to understand. This one is methyl, that is also easy to understand. But this one is complex, a branched side chain. A side chain which is itself branched, a complex one. In such case, what will you do? Let's number first. Numbering, let's do from the left hand side first. Left hand side, it is 1, 2, 3, 4, 5, 6, 7, 8. From the left hand side, if you number, the locants are 2, 3 and 4. 2 carbon methyl, 3 carbon ethyl and 4 carbon the complex one. And if you number from the right hand side, then what happens? It is 1, 2, 3, 4, 5, 6, 7, 8. If you number from the right hand side, then the locants are 5, 6 and 7. So obviously very clear, right hand side is wrong. So what happens? The left hand side is correct, right? So let's just erase the left hand side numbering. Now see, the right hand side numbering is erased. Okay, left hand side is correct. Now what happens to the naming? See, so obviously 3 ethyl will come first. 3 ethyl, ethyl E comes first, so ethyl E. Then 2 methyl. But we have a bulky one, a big complex one. What to do for that? In that case, if the side chain is complex, you have to number them again. That means this one becomes 1, 2, 3. What did I say? The carbon atom which is closest to the main chain will be numbered as 1. With the fourth carbon, if I just erase it and give a different color, see, if I consider the green carbon, the green carbon is closest to the parent chain. So green carbon will be given as 1. The green carbon is closest to the fourth carbon, closest to the parent chain. So green carbon will be given as 1. Then again, this methyl becomes a part of the side chain. Side chain of the side chain. Side chain of the side chain. So what will you do? Now see, again this becomes the parent chain of the side chain. Parent chain of the side chain. The complex will be divided again. This becomes, the green part becomes parent chain of side chain. Parent chain of side chain. Okay. Now see, the 2 carbon is having methyl. When you name a complex side chain, always put that in bracket. So 3 ethyl, 2 methyl. With the fourth carbon, we are having a big complex part. So how will you name it? 4 within bracket. Now within bracket what will you write? Within bracket you are naming the complex part. At the 2 position methyl is there, so 2-methyl. 2-methyl. 2-methyl what? 2-methyl propane. Propyl. Don't end it because we have not completed the nomenclature, full nomenclature yet. So 2-methyl propyl. That means with the 4th carbon atom, we are having this big complex part. And what is that complex part? It is 2-methyl propyl. 2-methyl propyl. The complex part is 2-methyl propyl. 2-methyl propyl. Now the next one is the side chain naming is done. We'll come to the word root. We are having 8 carbons, so oct. N, octane. 3-ethyl, 2-methyl, 4. The big complex part is subdivided. The complex part is subdivided. What do you get? The green carbon atom, which is attached to the parent chain, will be considered as 1. Green carbon atom is closest to the 4th carbon, closest to the parent chain, so it is given as 1. Then 2-methyl. 2-methyl propyl. Don't end with propane because we are not ending the name. 2-methyl propyl, this is the complex part. With the 2 carbon, methyl group is there, and that parent chain is propyl, having 3 carbon atom, propyl. If you end with propane, the naming is completed. You have not completed the naming yet. Then octane. Octane means again we are coming back to the main parent chain. We are coming back to the main parent chain. How many carbon atoms is it having? 8. So oct. All single bond, so N. If you want me to solve many more examples, if you have any doubt in any of the part, please tell me so that I can repeat it in my next video. And if you want me to solve many more questions regarding this complex compound, comment down. You can click a picture and send it in the comment. I will solve it in my next video. Okay, thank you everyone.